Alright, for the next section, we're going to do the graphs of the square root section right here. So I'm going to go ahead and work all 4 of these. So for number 11, it says, if the graph above, let me zoom in a little bit so y'all can see. That's better. It says, if the graph above was translated 4 units down, 2 units to the left, and was reflected across the x-axis, what would the resulting equation be? So here's my vertex, my starting point. If it goes 4 units down, so 1, 2, 3, 4, I'm here now. 2 units to the left, so now I'm here. And it's reflected across the x-axis, right? So this is kind of like my new x-axis. So instead of opening up, it's going to open down, just like that. So my vertex is -2, -2. So if I was writing that in an equation, it would be the square root of x, remember horizontally is opposite, so it's +2 underneath the radical, and then it goes down 2, so it's going to be -2 on the end. Now reflected across the x-axis, anytime something reflects across the x-axis, the negative goes out in front of the radical. So just like that. Alright, so number 12. It says, as the graph above was horizontally compressed by 1/2 and shifted down 3, what would the resulting equation be? So here's my vertex. Now, the horizontal, vertical stretch and compressions don't do anything to your shift, right? That's just, I always tell my kids, if I have a rubber band, just like this, here's my hair rubber band. Let me zoom out. Right, so like shifting makes your rubber band go up and down, left and right, up and down. But stretching doesn't move it, it just stretches it. So vertical stretch makes it really skinny, a vertical compression makes it really fat. But it's not going to do anything to the actual graph when it comes to the vertex. So for this one, I'm going to look first at the horizontal and vertical like shifts. So it goes down 3. So 1, 2, 3. So this is going to be my new graph right here, or my new vertex. And so that is -6, -3. So if it's a horizontal compression, I'm going to write my radical sign. So horizontal means you put the number on the inside and it's opposite. So instead of writing 1/2, I'm going to write 2. Open parentheses, right? And so my x coordinate for my vertex was -6, so I'm going to put +6 because it's opposite. And then I'm going to go down 3, so that's going to go on the outside. Be careful with your radical sign. Make sure it only goes underneath the horizontal part. And that's it. Alright, number 13, it says graph this equation. Find the equation of the inverse. So this means that the vertex is going to be -3, -1, right? Because horizontally you go opposite and down 1. So I'm going to go -3, down 1. So this is my point right here. Now I'm just going to pick another point so I can graph it a little bit better. So at 0, not 0. Let me pick a nice number I can take the square root of. So let's pick at 1. At x equals 1, right, you would get the square root of 1 plus 3 minus 1. So the square root of 3 plus 1 is 4. The square root of 4, the square root of 4 is 2. So 2 minus 1 gives us 1, not 0. So then my point at 1 would be 1, 1. So here's that point. And then I'm just going to graph it, just like that. Now it wants me to find, now looking at this graph right here, my domain is -3 bracket to infinity because -3 is included. And my range is bottom to top, so it would be -1 to infinity. Now for my inverse, it's going to flip. So my domain for my inverse is now what my range was. Oh, sorry, y'all can see that. My domain for my inverse is going to be what my range was for my regular function. So that's going to be -1 to infinity. And then my range is going to be negative 3 to infinity. So that answers this part right here. Inverse domain is negative 1 to infinity. The range is negative 3 to infinity. And then to find the inverse of this function, I always tell my kids that's that 4-step method. It's when you solve it algebraically when I'm looking for the equation. So here's the equation of the original function that they gave us. And then what I'm going to do is, it's in terms of y equals, so that's good. That's my first step. My second step, what I'm going to do is I'm going to switch the x and the y. So wherever I see a y, plug an x. Whenever I see an x, plug a y. My third step is now I'm going to solve for y. So get y by itself. So I'm going to add 1 to both sides. So you get x plus 1 equals the square root of y plus 3. Then I'm going to square both sides. So you get x plus 1 squared equals y plus 3. And then I'm going to subtract 3 from both sides. So you get x plus 1 squared minus 3. So that is now the equation of your inverse, and I'm going to replace it with function notation. So you get x plus 1 squared minus 3, which makes sense because the inverse of a square root function is going to be a parabola, a square function. So that's it. That's your equation. I'm going to go write it in my answer box. So right here, I'm going to get x plus 1 squared minus 3. All right, last one from this section, number 14. It says, list the transformation that took place from the function f of x in order to create the inverse g of x. So this is your original, and this right here is the inverse. So first, let's look, what did the vertex do? The vertex, all it did was go left 1. Y'all see that? And so this flipped over the x or the y-axis, the x-axis. Now I can't tell if there was a stretch or not, so what I'm going to do is I'm going to pick 2 points. So this is my function, y equals a square root of x minus h plus k. And so my vertex is 0, 0. So that's your h and your k. So you just get the square root of x right here. And then y. And then I'm going to pick another point here. Let me see. Oh, sorry, your h and k did change. Sorry, this is my vertex. So my vertex was negative 1, 0. Let me get a new piece of paper because it's hard for me to see. So my old vertex was 0, 0. My new vertex is negative 1, 0. And then my equation is y equals a square root x minus h plus k. So this is your h and your k. And then I'm going to pick another point on this graph. That's a pretty point. I like this point. So my x and y point is going to be 3, negative 4. See right here, I got my vertex, negative 1, 0, my x and y is 3, negative 4. So I'm just going to plug that into my equation and see what the transformation was. Your x is 3, your h is negative 1, so negative times a negative gives you a positive. And then your k is 0. So then you get negative 4 equals 3 plus 1 is the square root of 4. Square root of 4 is 2. So I get negative 4 equals 2a divided by 2. So this gives me negative 2. And the negative just means it flipped over the x-axis. So that's why that negative. So this is really a vertical stretch by 2. So I'm going to add that right here. Vertical stretch by 2. So those are all my answers to this part right here. And then when I'm writing my equation, right, it's going to be negative 2x, and then you go to the left one. So it'd be plus 1, and then our k is 0. That's our final answer.